We can wait for 5 minutes, sir.
Okay. I request all the participants to mute. Sudha madam, என்ன co-host மாத்திருங்க.
அதோ மாத்திடுறேன் சார்.
அரவிந்தன் ஆரம்பிச்சிடலாமா?
Yes, sir, we can.
நம்ம ரெக்கார்டிங் ஆரம்பிச்சிடலாமா? Very good afternoon to all the participants and faculty members. Am I audible?
Yes, sir.
So it gives me immense pleasure to welcome you all for the day 2 of 1 week national level students capability enhancement program for importance of data science. So this event is planned for 1 week. I welcome all the participants and my own faculty members. Now I invite Mr. Aravind to take over the session. Aravind, can continue now.
Yes, sir. Thank you, sir.
Thank you.
Okay. So hi everyone. to the day 2 of the session. Okay, so so yesterday I was looking at the chat, and so many of you had so many questions, like where the data is coming from, how the data is, and what are the things that we can do with the data and everything. Okay, let me start this session by answering some of the questions from you. If you have any questions, just please post it in the chat so that I can answer that first, and then I'll proceed with this session, because I think you will have so many doubts about what data science is, how everything is done. Yesterday I saw a lot of people are asking what how the data is collected and how the data is coming from different sources. So if you have any questions like that, I'll just post it in the chat so that I can answer it one by one, and then we can proceed with the session today. Let me answer the first question. Which software does data scientists use professionally? Okay, so data scientists use mostly it's like not a there is no definitive answer if you ask me about professional software, because everyone use their own kind of software for viewing the data and getting the insight. The only thing that is more important is getting the insight from the data. So what the data is saying, so how can the decisions can be drawn from the data, and what are the decisions that can be drawn? And there are different types of methods, like unsupervised learning methods, like I'll show you. Like today we'll see linear regression, and we can see how the workflow is and how everything is fitting into place. It's like a big jigsaw puzzle. We just fit every pieces together so that we can get the insight of what the picture is. So it's like a jigsaw puzzle. So everyone uses different types of tools. Mostly we'll use R and Python. It's a programming language. I'll show you the packages that we use, because there is a package called Anaconda distribution. So we'll see that today. We'll see the workflow of how everything is coming. So let's see that. Okay, so what's the next question? So when was data science first used? Data science was first used. There is not a definitive time, because everyone is using is getting some insight from a data from the time data started generating. For example, if you can say that there is a disease outbreak in London back in around 1800s, I think. So they gather the data and they get the insight from the data. So that's probably might be the first time where data science is used in a very small scale without computers. So data science is basically getting some insight and information from the data. It's not like we take the data and do this process and get the answer. It's like a art. What I said yesterday, it's like an art, like getting the data and giving some insight. So that's what was the basis of data sciences. So that's what we are going to see how it is done today. Okay, let's see the second one. Sorry, let's see the next question. After 12th to become a data scientist. After 12th, you can take data science, or I think the specialization, I think now it's somewhat popular in India, because the data science, every colleges are taking data science now. So you can choose that. It specifically focuses on data science. So you can select that one. Okay, what's the next question? If there is any library for data processing in C++. Okay. Since I told you yesterday, okay, let me tell you something simple. Okay, let me tell you something simple. So what it would take you to write a program to print mathematical tables. in C++, if you take a program and let it to print, for example, two tables, it will take you around like 10 or 12 lines to do all those things. But in Python, it will take like 3 lines or even shorter. So that's the power of Python. It will be like the program will be short, and it will be easy for you to program. That's why we use Python. Okay, so there are if you take the libraries, for example, that is written in Python for using in Python, like the pandas, scikit-learn, and other powerful libraries that we use in data science, are programmed using if you know about Python, there is another language that is combining both C and Python. That is C Python. There is a library called C Python, or somewhat like similar to that. So they use C and Python to produce their those packages like pandas, NumPy, and everything. So that is much more faster. That's there is no specific library for C++, but there are libraries that are written in C for Python for performance. Okay, the next question: data science and data analysis are same or different? Data analysis is getting some insight from the data, if you say basically, and data science is it is a process of using machine learning algorithms or machine learning models to get some insight. It's just like an expanded version of data analysis, if you in my opinion. Okay, so the next question is why data science is important. Okay, let me tell you something about. Okay, let's take Android operating system. So there are lots and lots of data that is gathered by Android operating system. For example, it knows about your location, it knows about your phone number, it knows about your browsing patterns, it knows about your day-to-day life of what everything that you're doing. Right now, if you're viewing this presentation from your Android phone, it is gathering a lot of details like who is participating, who is doing everything. So everything is data for it. So what is the best thing that it can do with the data? Okay, let's see what it does with the data. This is a pure data science and machine learning perspective of what Android is doing to the data that it's collecting. It might differ because I don't know how they do it, but this is what simply they do. We are using data science and machine learning. So let me tell you what they are doing. Okay. So for example, you're going to Google and searching for some maybe some funny videos, and you going to another tab and browse for some food items like biscuits or cakes. Okay, and then you go back to YouTube and you will see ads that is containing biscuits and the things that you browsed in another tab. That's what they do with data science and data insight that they are gathering about your browsing patterns, and they're just doing so that they are doing the targeted advertising. That's one application of data science, if you ask me. So they are doing a lot more than that if you get it into the perspective. But this is somewhat basic thing that is happening with Google. So I think that answers your question, I guess, because their data science is very important in every field. So it fits into all the fields in engineering, science, and everything. So that's why data science is important these days. Okay, so what we will cover in this program, is there any code? Okay, now what I'm doing now is I'm just answering your questions, because a lot of you have so many questions. Because once we get clear of that, I'll show you a code of how linear regression is done, we'll see the house price prediction today. We will predict the house prices based on different parameters. It will be somewhat, there will be some code and programming things, and it will be somewhat interesting. I'll just show you the code in a little bit. Okay, it's linear algebra, probability, and statistics we learned in school would suffice to start working in data science. Yeah, linear algebra that you learn in high school, like in 11th and 12th, it's more than enough. Because every mathematical models, every computer science thing is having some basics in linear algebra. And probability and statistics, the basic thing what you need to know about probability and statistics for data science is there is infinite number from 0 to 1, because there is no definitive number between 0 and 1, because there is a lots and lots of numbers between zeros and 1. That's what probability just deals with. So that's what you need in probability. And some basic methods like conditional probability and Bayes rule. So a lot basics. You need to know basics, because you need to understand stuff what the model is giving you. So that's what you need to know. Okay, so statistics. Okay, statistics for if you want to understand the data, then you need to understand the statistics. Okay, let me today show you how everything is like. We will describe something, and we will see the statistical interpretation that we can gather from the data and how we can process the data using statistics. I hope everyone here knows about two-dimensional graph, because you know how to plot a graph and where the points lay in a two-dimensional graph. That's the knowledge that is more than enough for today's session to understand what is happening. I'm just going to show the workflow, because it will be somewhat more technical, and you can get some inspiration from that, and you can proceed with learning more details of what a model is, how the data pre-processing is done, and what is data set, and everything. Okay, we'll go through it. Okay, so what is the future of data science? Okay, data science, if you ask me, it's in infancy, because there is a lots and lots of data. There is big data. In big data, for example, if you have a 1 billion records, then there is not a efficient program or efficient model that can process 1 billion data and produce into an output. Because if you take a processor from your own computer or something, it can process maximum up to 10,000 records. To process 1 billion records, it will take almost like 2 or 3 days, maybe even a week, maybe even a month, depends upon the data. If a data is an image or a video, it will take more than a month, more than 6 months. It will take for a data to process and produce the output. So I would tell you that the data science is still in its infancy when dealing with big data. There is a lots and lots of research that is happening on how to deal everything with big data and do it much more efficiently and much more accurately. That's what data science future is. So is there anyone having any other questions, or shall I proceed? I'll wait for another 2 minutes so that you can post your questions, so I can answer that, and we can proceed with today's session. Because now I think you can guess somewhat where we are going about the data set, and how everything is coming into place. Yeah, okay. Is data science important for mechanical engineering? Okay, mechanical engineering. Yeah, obviously, because if something has a data, then there needs to be some insight about the data. If mechanical engineering has some data, then it needs some insight to get some output that we are desiring. So whenever there is a data, then data science is important. In mechanical engineering, in medical field, in virology, everywhere where there is a data, then we need data science to get some insight. Yeah, I think that answers your question. As data science is used in IT engineering. Yeah, since as I previously mentioned, if there is a data, then there needs to be some insight. So whichever fields that generates data, it needs data science to get some insight. Yeah. Any other questions? Okay. So what is the accuracy percentage to predict a data? Okay, we'll see because in data science, accuracy doesn't matter. And I'll tell you why accuracy doesn't matter. There are lots and lots of other parameters that we evaluate a model rather than accuracy. Because if a model is model means if an algorithm is doing it 100% accuracy, then the algorithm is not doing its work correct. That's what machine learning algorithm and data science model that we need to evaluate. I'll show everything in today's session. Okay, I'll start with the session today. So you can see how the workflow is and how everything is fitting into place, because it will be like a huge jigsaw puzzle. We'll take all the pieces of the puzzle and then we'll put it into a single unit and get some output. Okay. Let me share my screen. So okay, nice. So I think everyone can see my screen. Okay, let me start with today's outline, and we'll get to machine learning model implementation, and we'll predict the output for the test data and how we evaluate the model. There are different types of parameters that we evaluate the model. We'll look at it. We'll look at everything today. I'm sorry if it is. It's going to be a somewhat lengthy session because I'll be explaining in detail what is data and how everything is fitting into place. So please be patient with me. So let me tell you about the outline today. So I'm just going to explain all about data, and then I'll tell you about understanding the data and the basic statistics of the data and visualizing the data and pre-processing steps and basic data pre-processing, data cleaning before model design, and understanding the difference between regression and classification, implementing a basic model and fitting the model into the data and predicting the output for test data. So this is going to be the outline for today, because everything that I'm telling you, I'll be showing you through a program. So it will be somewhat interesting to see the code and the output. Let's get on with it and see how everything comes into place. Okay, the package that we use is Anaconda 3, Anaconda Navigator. just we launch it. I'll answer all your questions after the first section of data pre-processing, so that you can understand so you can ask me some questions, because it will be somewhat difficult if you don't understand what happens in data pre-processing. And then we'll proceed to machine learning model implementation. That's what we are going to do today. Okay, let's see navigator using over here. So to download this, you can go to browser. You can go for Anaconda Navigator, and this is the, you can select the individual edition, and it will take you to the website. And here you can just click download, and it will just download it for you. I'm just canceling it because I installed it already. So once you installed it, this launcher will open, and this will show you the Anaconda Navigator over here, and the Jupyter Lab. This is what we are where we do all those stuff. Let's launch it. Okay. Let's go through this program. Okay. This is what we are going to do today. I'll just open the data set. Okay. I think you know what is a data set is, and what and how the data will appear, because you can see there is a lots and lots of columns. There are so many records in it. I think you are much more familiar to this, because this is a simple data set. There is lots and lots of columns in it. There are lots of rows. There are different types of columns that specifically says the different parameters about the house. So let me tell you what this data set says. First, plainly, before exploring or before doing anything in Python, just let's see what this data set does. So data set says. So what this data set is about. If you see the first record, it will say the different different properties of a particular house. For example, if you see this column, it will say the neighborhood. Neighborhood here means if in Chennai city, there are lots and lots of neighborhood like Anna Nagar, like Ambattur and other places. That's what the neighborhood here means. So the condition specifies it's in normal condition, and the building type, it says, is one family building, and the house style mentions it's a two-story building. Two-story means it's a two-floor building. So this is how this single record mentions about a particular house. So we have records of like 1,461 houses. So this is the sales price. So this is the value that we need to predict. This is the value that we will program the computer to predict and give us the output. So this is what the data set says. The individual columns specifies the different properties, and the rows will give you the records of the individual house. Okay, let's go to the Jupyter Lab, and we'll just go through it. Okay. Let me just open a new workbook so I can go through step by step and explain you what happens for individual output. Okay, let me just import all this. Okay, in the first section, what it is happening here is we are importing header files. If you are familiar with C and C++, these the header files are hash include stdio.h. If you are familiar with C++, hash include iostream.h. So those are the header files. These are the header files that that we need to include for this problem. You will get into all what are these header files and how these header files are used. You will get used to all these when you explore into this more. Let's import the data first. Okay, so our data set is imported. So in Excel, if you see, the data is like this. So in order to visualize the data like this in Python, what we do is if you print, if you just, I'll just print it. If you see the print statement, it is just printing all the records. So there are different columns. There are if you can see that there are 1460 records and there are 81 columns. In Excel, you can see that all the 81 columns over here. This is how we just explore the data set once we imported the data set. Okay, let's proceed to getting some statistics, because exploring the data set and looking at the data is what we done in Excel. So let's just go and explore and get some statistics out of the data set. Okay, let's do that. Okay, so what it is saying, you might be familiar with statistics like mean, standard deviation, minimum, maximum, 25th quarter, 50th quartile, and everything. I think you might be familiar with all those things. So that's what we are seeing over here. Let me just explain you some basics over here. If you see the first thing, that is count, and let me just zoom in a little bit so you can see it clearly, more clearly. I'm sorry if I missed all this. If you missed all this because it's somewhat zoomed out. Let me just go through it fast. The code. Let me just zoom in a more. These are the header files, and here I am just importing the data. The next, I am just displaying the data that is in the data set. Next one, we are getting some statistics out of the data set. In the first row, you can see the count of the values. So we are having 460 records. We know about this here because there are 1460 rows and 81 columns. And the mean, you know about statistics, right? Mean is the value that we add everything and average it out. So that's what mean is. So the standard deviation is how it's deviating from the mean. So that's what standard deviation is. And the minimum, maximum values are minimum is 1, because in our ID field, you can see that it starts from 1 and it ends at 1460. So that's what it's over here, 1 and 1460. In the ID column, it's just a continuous value because it doesn't specify anything about the house. It's just mentioning it. The data is from 1 to 1460. So if you see the next column, MS subclass, the count is 1460. So it's still having 1460 values. And the mean is 56 and the standard deviation is 42. And the minimum is 20 and the maximum is 190. If you can understand what the basic statistics of this says, you can proceed on pre-processing this data. Because in data science, the flow will go like this. We take the data, pre-process it, clean it, introduce into the model, and get the prediction. So that's what the basic workflow is. That's what we are doing over here. It might be somewhat difficult for you at first, but it will be somewhat more easy once you get all the information, and once you know the workflow and what the data is saying, it will be somewhat easier for you to implement all this in the future. Just observe what we are doing in here, so that you can get somewhat basic workflow, because you already know the jargon words like data science, machine learning, artificial intelligence, natural language processing, and all those fancy words. You might have seen the videos of Tesla auto driving cars and everything. So this is the basic workflow of what is happening. Let's get going. Okay. I think yesterday Mr. Ramar might have mentioned about correlation matrix. So, and what a correlation matrix explains, and what correlation matrix tells you, and how everything is correlated between the data and everything. Let's see how the correlation matrix works, and what is a correlation is, the correlation, how we take the data as a data set for the model. I'm just explaining it in much more simple terms, but it will be somewhat complex if you take much more, if you explore it on a much more larger scale. Let me just explain you in a simple way, because if you see this big graph with different colors, it will be like what it is saying, because it's of different colors and I don't know what is happening over here. Okay, let me just tell you about correlation is. So there are positive correlation, negative correlation. So what is a positive correlation? A positive correlation will, when there is a positive correlation, both the values that we are comparing will move in the same direction. So for example, the subclass value increases with the sales price. So this is where two columns is moving in the same direction. So what is a negative correlation? Let's take the same example. MS subclass value decreases when the sales price increases. So this is what a negative correlation is. Let's comment this out, and we'll see what's a positive correlation and negative correlation. As I mentioned before, there is infinite number of values between 0 and 1. In probability, we deal with values 0 to 1. So that's what we are going to see now, because just bear with me. It will be a huge matrix of numbers. I'll be explaining it simple, so just please bear with me. Okay. If you see, this is a huge matrix. This is a huge matrix compared to the small thing and the small thing above. It's a huge matrix. It says a lots and lots of values. It's between 0 and 1. And there is minus values and there is plus values. So what these things says? So I told you about the correlation, right? There is a positive correlation, there is a negative correlation. If the values are positive, then it's moving in the same direction. If the values are negative, then it's moving in the opposite direction. So this is what that is telling you, and what is happening over here. So if you take sales price, let's see sales price. We can see there are lots and lots of columns that is corresponding to sales price. If you know about linear algebra, then you know how to compare what matrix is on the x-axis and the y-axis, and it will just let you interpret what is happening over here. For the sales price, the lot frontage and the sales price is having a positive correlation. So the lot frontage, and if the lot frontage increases, the sales price increases. If the lot frontage decreases, the sales price decreases. Reciprocally, if the sales price increases, the lot frontage increases. If the sales price decreases, and the lot price decreases. So that's what we are seeing. So where we can use this information and how we get okay. For predicting the sales price, we need only the positive correlated values. Because if you take negative correlated values, and it doesn't impact the sales price, because for example, the MS subclass, this is the second column over here, it is having negative correlation. So there is it doesn't affect the sales price. So this property, for example, the number of bedrooms affect the sales price. But if the neighborhood doesn't affect the sales price. So that's what I'm trying to say about by using this correlation matrix. So this is how the Python statistical engine will give you the information about the data and the data set that we are dealing with. Okay, let's go with just give me a minute. Okay. Okay, let's just go with much more pre-processing. I'll just explain another 2 or 3 sections, because I think that will be somewhat enough to explain, because it will be somewhat more difficult for you to understand much more after this another 2 or 3 sections. I'll skip that, and we'll go straight to the model implementation. Then we'll have a Q&A session before we're going to the model implementation, so you can understand what is happening over here, and we'll proceed with the session. Okay, let's see what I'm doing over here. As I mentioned before, we need to take the highly correlated columns in order to predict the sales price. So that's what I'm doing over here. I'm just taking the highly correlated values and displaying it in a correlation matrix. The correlation matrix over here, I'm just displaying the highly correlated value and the correlation matrix over here. Okay, let's go to another one. Okay, since as I told you before, we don't need the negatively correlated values or the values that have low correlation. So what I'm doing over here is I'm just removing the values that have low correlation and have the columns that have more empty values. So that's what I'm doing over here. So after doing everything, I am just seeing the correlation matrix. You can see that columns have been reduced than before. If you see, there are lots and lots of columns. So in this, it will be reduced to somewhat. Let's go to the next one. Okay. So there are different types of problems with when dealing with the data. So let's take a simple data, for example. Let's create a data let's create a data set. Let's go to Excel and create a data set. Okay, you can see the data set over here. You can see in the first row, sorry, in the second row, you can see that there is no missing values. In the third row, you can see different types of values. The machine learning models will only take numerical values. If you see the second row, it is having a not available value, and there is a value that is specifying it as an absent. So this is the same thing for the third value. So that in our data set, you can see that there is a NA over here, and the LVL, BNK, and everything. We need to deal with everything because we need to change everything into a numerical form in order to get the in order so that we can pass it into the model and get the prediction. That's what I'm doing over here. I'm just exploring the missing values. So if you see the pool QC column is having 99% of missing values. So we'll just deal with that over here. Okay. Let's just see what the data set now look like. You can see everything is nice and neat, and the data set, you can see the value that has NA, that is Ali. That the column is missing over here. So we don't need that column, because if there is lots of missing values, then we can't compute anything from it. So that's what we are doing over here. We just remove the columns and we clean the data. That's what we are doing over here. Okay, if you see the statistics over here in the bottom, it says 5 rows and 52 columns. We started with 89 columns, and we are up to 52 columns. And the head function will just display the first 5 records. Okay, let's proceed with the next part of pre-processing the data. Okay, so if you see this, it is a let me just explain you by this simple example. Okay, so if you see the category column, it has A, B, B. So what I'm doing is I'm just encoding it. I'm just changing the values A and B like this. You can see that the text values have been converted into numerical values. So that's what we are trying to do over here. Okay, let's proceed with the next one. Let me proceed by executing all this, because it's somewhat difficult. Let me tell you what I'm doing is I'm just doing the much more extensive work of pre-processing. We'll see the data set that we explored like before. We use the head command to display the first 5 records, and you can see how the data is transformed and every value is changed into numerical form. Okay, everything looks fine. Okay, so what we have done is we converted every value to the numerical form. You can see number of columns has been extended. So if you see here, the extra quartile, there will be additional columns that I'll just explain using the simple example. What I'm doing over here is for the category A, I'm just choosing 1. So I'm just choosing 0, 0. So for I'm choosing column A, column B. So this is how I'm transforming the values now. So that so you can see there is not lots of additional columns. Okay. So is there any other process? No. Yeah. I think you have the. I think now you can have some basic idea of how we process the data and everything is fitting into a jigsaw puzzle, and what is the basic workflow, and how statistics, how probability is getting into one place, and lets us understand the details of the problem. And you can also see that how mathematics are just involved in data science, and what is the basic workflow of it. Okay, now we can have some Q&A so that you can ask me some questions, and tell me if you don't understand the topic, because this is somewhat complex topic. I'm just giving you some overview and the flow of how everything is done, because I think before this session you might have some knowledge about this, or you might not. And you will have now you can see that how everything is done, because this is how we do everything step by step. Take the data and clean the data and get it into a working form that our model can work with and produce the output. So this is how basically what we do. So this is the basic process. There are much more pre-processing that we can do, and get the data into much more cleaner state than this. Okay. I think I miss a step. Just give me a minute. I just missed a step of pre-processing, and then I'll come to answer the questions, because without that it won't work properly. Okay. Now I'll just answer your questions so that you can. I'll just tell you what everything is, and how everything is getting into place, and clear your doubts. Then I'll proceed with the model implementation, and you can see how our extensive data processing has come into a beautiful machine learning model, and how we get our output very nicely. Okay, I'll just stop the share and answer your questions now. Okay. Okay, the first question, can you suggest some introductory textbook on practical data science? If you see, there are lots and lots of textbook, but I would suggest you start with Kaggle. There is a website called kaggle.com, and you can get started with it. I'll just I'll just message the link. I'll just message the website to the chat, so you can get started with that. And started with the practical. I would suggest you to get into a proper degree, so that you will have everything, like from the basics, like the mathematics that are needed, and much more in depth. Like they will give you like much more in depth knowledge of this subject other than the textbook. So I would suggest you to enroll in a course. So that will be the best. Okay. So the next question is, what will we do if we don't have full data? Okay. You can see the pre-processing steps that we done over here. So there are different types of pre-processing steps that we can do. Because in this session, I showed you pre-processing of the data that I have. There are different types of data sets, and those data sets will require a lot more pre-processing than this. I'm not telling you these are the things that you need to do, because for linear regression, you need to do pre-processing steps like this. Like you can't have any text data or other data. But in classification, you can have some text data. It will classify the text. So pre-processing differs from method to method, and from data to data, and the problem to problem. You need to explore the data and get to your pre-processing pipeline. That's what I'm saying. You need to understand the data and get the insight from it. That's what we deal with data science. So this is how I am just telling. Okay. Next question. Okay, if you have any doubts, please put it in chat so I can answer it, and then we can proceed. Because the next thing, we are going for model implementation, and it will be very hard if you don't understand what everything is said. Just post it in the chat. So I'll just give you 5 more minutes. And after 5 more minutes, we can get started with the model implementation. And then we'll have another Q&A session. So you can ask me some more questions. Then we can okay. So who do you admire the most? If you ask me about my inspiration, I started data science after looking at a person called Andrew Ng from Stanford. I think most, if you explored some data science, you know who is he. So he's the person who I inspired to learn data science. So he's the person. Okay. So what is Jupyter? What is Jupyter? Jupyter Lab is a software that where you can just type the code and get the output in the same page. It's like a web application. You can say. You can see that I'm running it in my browser. There are tabs that I switch in between the browser window. So that's what Jupyter is. It's a software. It's a package that comes with Anaconda distribution. Okay, which college did you study? I think you might have attended the previous session yesterday. I'm an alumni of SRM Institute of Science and Technology, MCA, 2014-16 batch. So now I'm doing my research in University of Adelaide. So that's my education. So any other questions? Okay. Do we need a degree to study data science? Okay. As I told you before, it would be best if you join in a course and do the data science, because it will give you more information than reading it online or doing the courses online. It will be best to join a course that is specializing in data science, to learn more about data science, because they will introduce all the mathematical concepts and put all the parts of jigsaw puzzle together and give you much more knowledge about that. Okay, so why we need data science? I think I've already answered this question before. Okay, let me just give you like simple thing. Okay, where there is data, we need data science. So that's pretty much where we need data science. Okay, so what's the best college for engineering in Chennai? I honestly don't know, because I'm in Australia for almost like 2 years, so I honestly don't know for engineering. So any other questions? Any other questions? Okay. So I think so many of you are asking personal questions. Okay. Let's just stick to topic of today, because yeah, stick to the topic of today. Okay. I think I've answered the difference between AI and data science before. Okay, let me just continue with the topic. So we can just proceed with the topic. Okay. Okay, let me just show you the other thing. Just share the screen. Okay, let's proceed with a model implementation. Okay, so what I'm doing over here is I'm just splitting the data set. I think I hope everyone's screen is visible a lot, and you can see the data set train and data set. The data set is split into X and Y. Let me just show you the how everything is done. Like you can see the presentation over here. He is like it is like you can see the X and Y axis over here, and in the X axis there is a sales price. In the Y axis you can see the you can take this Y axis as number of bedrooms and everything. So this is a two-dimensional graph. Okay, so this is a two-dimensional graph. Let me just draw. Draw the thing. Please mind with my drawing. It's somewhat not good. Okay. Okay. So you can see the basic of what I'm doing over here. So in X-axis, there is a sales price. In Y-axis, there is a number of bedrooms. You can see the linear regression line over here, and you can see the plot points over here. So the this is what linear regression is doing over here. Let me just go to the program now, and we'll see how we do it over here. Okay, you can see the X and Y axis over here, and in the X axis, X train test, Y train, Y test is over here, and the train test split. So this statement, what I'm doing is, why I'm doing the splitting of the data is I need to get the train and test set. I need to train the model and I need to test the data from the model. That's what that's the basic of what I'm doing over here. Okay, so once we split the data, we'll just implement a model over here. Okay. You can see that the linear regression, the first line, I'm just implementing the linear regression. And in the second line, I'm fitting the data. In the third line, I'm just doing the prediction. And in the fourth line, as I told you before, the accuracy doesn't matter for a machine learning model. It's because you can have almost all the if the model just fits the data perfectly, then it won't generalize the prediction. So what is generalizing? Generalizing a prediction means we need to loosely fit the data. So that's what we need to do. So for evaluating that, we are just doing the mean squared error over here, and we just do the root mean squared error over here, and the R2 score. These two are the parameters for evaluating the linear regression. Okay, we can see the two scores over here, the RMSE and the R2 scores over here. These two are the scores that we need to evaluate and interpret, and we just okay, let me tell you an interesting fact about these two scores. So what these two scores mean, and how these two scores should be, and how we evaluate what's the graph below it shows. Okay, so the RMSE value should be low. So if you take in the probability standpoint, it is between 0 to 1, and it should be close to 0, and the R2 value should be close to 1. You can see that our model is doing a perfect job in this. In this graph, let me just zoom in the graph and show you. You see that the actual plot is over here, and the predicate plot is over here. And this is what this graph shows you. Okay. So now you can see that how you can see the basic workflow of linear regression and everything. So these are the things that you will learn in data science. So I would suggest you to enroll in a course for doing data science, because it will give you much more information than that, than learning anywhere, because you will have some guided experience, and what these things do, and do all those how data fit and how everything fits into place. So that's how I would suggest you to get enrolled in a course and do it. Okay. I think that if anyone have any questions, we can answer. I'll have another 5 minutes, so we can answer the question. And if you have any questions, just ask me. Then I will answer those questions about this session today. And because I've already answered a lot of questions about my research topics and everything yesterday. Okay, so if you have any questions, just post them in the chat so I can answer that. Then we'll proceed with it. Yeah, I told you about my topic yesterday. If you have any questions about the presentation today, what are the topics, what are the informations that I gave, just please post in the chat, and then we can proceed.
Participants, you can ask your queries now. Or you can post in the chat box also.
So, which is the best website to learn PH? I think the question is incomplete. Okay. Okay. Which is the best website to learn Python? I told you before, like you can get started by for data science using Kaggle. It is the best place to start, but it will be a lot harder because I think you will it will take you a lot of effort, because without any guidance it will be a lot hard for you to learn by using a website. Because yeah, it will be useful to start from Kaggle. Yeah, just start from Kaggle. So I think there is no doubt in this session. So I'll just continue with my session tomorrow, because tomorrow we'll be seeing image classification. It will be somewhat interesting to see the image classification.
Students, if you have any clarification, you can ask. We will send the attendance link shortly. Arvind, any doubts you can clarify from the student side?
Yes, sir. If they post the doubts in the chat, then I can answer that, sir. Because I think today's session is somewhat complex, I guess.
Okay.
I can see someone raise their hand. If you can post your questions in the chat, and I'm happy to answer the questions. Okay. Okay. Can we analyze a story with data science? If yes, for what? Okay. To tell you about the basics, like okay, you can do a classification problem for a story. Like you can give the machine learning model lots of stories, and then you can tell it to predict whether the story is good, bad, or in the middle. You can do a data science classification on that for the story. Yeah, you can do that. You can do the data science like that for a story. So if you see the general flow of what we do with data science is the thing that I showed today, because we start with the data, we clean the data, and then we get the prediction out of the model, and it will be somewhat close. We can see that from today, lots of things are dealt with only data cleaning and data pre-processing. That's the basic thing. Okay, let me ask you a question. Okay, for tomorrow's session, you just choose between these two topics. I'll just tell you the things, so you can just tell me what you are wishing to you are willing to see. We'll go with that. Let me just wait a minute. I'll just tell you the topic. So. Okay. So there are like just a minute. I'm just opening some. Okay. So there are two classification problems that I would show that I would like you to choose. So which one of you, which one do you want to see? Okay. So the two problems that you can choose from is like, one is plant seedling classification. The another one is natural language processing. I'll show you how to process the natural language processing of classifying reviews. For example, you are going to a restaurant and there are like positive reviews and negative reviews. From the review that is written in the website, you can detect whether the review is positive or not. So those two problems, there are those two problems. I can tell you. So I'll you can post it in the chat. I'll just show you the problem that is that most of you tell me. The first one is plant seedling classification. The next one is the natural language processing. Okay, natural language processing. Okay, any more? Okay. Okay. So most of you are willing to see natural language processing. Okay. Okay. Okay, so I think natural language processing is somewhat interesting topic. I think. Okay, plant seedling processing, natural language. Okay. Okay, natural language processing. Okay, I'll show you natural language processing, but for that, I need you guys to go to the internet and browse naive bias classifier. Just read about that, and I think it's based on Bayes rule in probability. So the hotel reviews are natural language processing. It's image classification. So both are under both came under classification. Both came and both will come under classification. Yeah. Okay, so I want every one of you today to go and search for like naive bias and Bayes rule in probability and statistics. I think it comes under conditional probability. I'll just post it in the chat so that you can browse that. So this is the spelling N-A-I-V-E, naive bias, B-A-Y-E-S, naive bias. And conditional probability. Yeah. So those two things you just browse today and get some insight. So we'll see how we do the natural language processing. And I'll be asking some questions about what are the techniques that you know and can be done for the text and sentences. Yeah, we'll just see about that tomorrow. Yeah. So anyone has any questions about the things that we did today? Or shall we just close this session and we'll see tomorrow?
Any clarifications for students, or we will wind up today? Arvind, what will you do? Will we wind up now?
Yes, sir. Yes, sir. We'll complete today and tomorrow.
I take this opportunity to thank Mr. Arvind for taking day 2 session and all the participants of various schools. And I thank the faculty members for making this function a grand success. Participants, please attend all the days function as advised by the guest speaker. Thank you all. We'll all meet tomorrow at the same time, 3:15. Thank you, Arvind. Thank you, participants. Thank you, Sudha, madam. Thank you, Rajkumar, sir.
Thank you, sir.
Thank you, madam.